Hello everyone, in this video we want to talk about third law thermodynamics. So stay tuned with us for further explanation.
So, what is the third law of thermodynamics? Third law have said that perfectly crystalline solid at absolute zero has an entropy of zero, as this is the most ordered state that the substance can be in. Entropy is measured in joule per Kelvin. Absolute zero is the lower limit of the thermodynamic temperature scale. Absolute zero is defined to be negative 273.15 Celsius or 0 Kelvin. Note that entropy is not a measure of energy itself, but how energy is distributed within a system. It is enthalpy, the thermodynamic quantity we learned about that is more accurately describing the energy of a system. As we will see, enthalpy and entropy intricately related to tell us something about the Gibbs free energy of a system.
Okay, next we go to Gibbs free energy formula explanation. G or Gibbs free energy tells us whether a process will be spontaneous or not, meaning if it will simply happen on its own. Chance in Gibbs free energy is given by this equation, which include change in enthalpy, change in entropy, and temperature. If delta G is negative, the process is spontaneous. If positive, it is non-spontaneous. So, we can use this equation to see how a spontaneous process can be either enthalpically or entropically favorable. For example, if delta H is negative, which means exothermic and energetically favorable, and delta S is positive, which means an increase in entropy, which is favorable. A negative minus positive will always be negative or spontaneous. If the opposite is true and both are unfavorable, we have a positive minus a negative, which will always be positive or non-spontaneous. If only one of the two is non-favorable, we have to do some math. If delta H is positive or endothermic, that energetic unfavorability could be outweighed by the other term if the process is entropically favorable, and since T is here, this factor will increase with a larger T, so entropically favorable processes are more likely to be spontaneous at higher temperature. Conversely, if it is energetically favorable but entropically unfavorable, the entropic unfavorability will be minimized at lower temperatures. This is very important equation to understand.
Oh, it's already at the end of this video. Before we end, it's a calculation time. We will show some examples that using Gibbs free energy calculation.
As we can see, we want to find the temperature or T in this reaction. The reaction of Br2 in liquid state to become gaseous state was already in spontaneous reaction. Okay, now let's see the information given. By using Gibbs free energy formula, if we want to find T, we must simplify the formula until we got this. Now, we just enter the information that we already have into the equation. Finally, we have known the amount of T. Based on the theory, this calculation have proved that when delta H and delta S are more than 0, the reaction will be spontaneous at higher temperature. Okay, that's all from us. We hope that this video will give some knowledge about third law of thermodynamics.